Hello. In this lesson we will learn about the concept of object-oriented programming and classes in Python. So what is object-oriented programming? Object-oriented programming is a way of writing code in terms of different objects. So let's say you want to create a new object like a cat. What would you do? You would list down the properties like the color, the size, and you will write code for each of them property. For each one of those properties. So what if you wanted to create multiple cats? Would you have to go every time and create new code for the different cats? The answer is no. You can provide something like a blueprint that we can just use every time we want to create a new cat. The mechanism that makes this blueprint work is called object-oriented programming. And we can use this blueprint every time we need to create a new instance of this object. In this example, a new cat. So now let's say you wanted to create a dog class. The dog class would have many similar elements to that of the cat class. So for example, the color and the size are both parameters that you have to take into account for both of these things. So there is a way we can create another class that is called the parent class. And this class can include all of the similarities that these two children classes have. So for example, the color and the size can be a parameter at the parent class. So for example, we can have the class of animal, and this class can have the similarities of these two child classes. This concept is called inheritance, and we will get into depth later. Okay, so now let's take a look at how to create the actual cat class. So first of all, we begin with the keyword class and then the name of the class, and then we define this function. Okay, so let's start explaining. This here method is called a constructor method, and this method is called immediately when we initialize a new cat object. So whenever we create a new cat, this method will be called at this time. And the self here means that we can access any attributes or methods inside of the class. Okay, now let's take a look at how you can create a new class. A new object. So you can call this cat1 equals to cat. So this here creates a new object of type cat. But now let's add a few attributes to the class itself. So we can have a cat's count equal to 0. And here we can just add name, size, and color. And instead of none here, we can go ahead and add self.name equals name, self.size equals size, self.color equals color, and finally cat's count plus equals 1. So what this does is we can take all of the parameters here and assign them to the different class attributes. So let's actually specify them here when we create a new instance of cat. So we can call this Tom1, we can give it a size of 2, and the color of this cat is black. So how do we access each of these attributes? The way we can access them is with the dot operator. So if I wanted to print the name of the cat, I would just do print cat1.name. So now if I run this, you can see that the name of our cat is Tom1. Okay, so there are two types of variables when you are talking about classes. So the first one is instance variable. So for example, the name, the size, and the color is an instance variable because it will be different for each time we can create a new object. And there are also class variables like this one here. So cat's count is going to be the same globally on all of the instances. So for example, if I came here and created another cat, so I can call this Tom2, I can give it a size of 2, and I can also say it's white. And I can also create another cat. Let's call this Tom3. It's going to be size 3 and gray. Okay, so now let's go ahead and print this. Print whatever we need. So I'm going to print the count of cats, which is going to be the cats count here. I can also print the name of cat1, and that will be Tom1, cat1.name. I can also print the count of cats for the second cat. So what does the second cat think the count of cats is? Okay, and finally let's print the name of cat2. This is going to be Tom2. Okay, so let's run this and see what happens. Okay, so you can see that the count of cats is 3 for both of these, and that's because here we have a class variable that doesn't change for different instances of this class. So we have different instances for the class cat, but the cats count is the same for all of them. Okay, so the reason that classes are so powerful is because we can add different methods inside of the class. So for this example, I'm going to just delete the cat3 and all of the printing statements, and I am going back inside the class, and I am defining a new method called meow. Okay, and this has to be self as well. So inside of the meow method, I am going to print self.name, and also is meowing. I'm going to add a new method called eat, and I'm just printing the name of the cat plus is eating. Now I'm going to create another one called run, and this is just going to print the name of the cat and then is running. Okay, so now let's leave these as they are, and now I can go ahead and call cat1.meow. I can also do cat1.eat and cat1.run, and of course I can copy this and just replace cat1 with cat2 and do the same thing. So let's run this. So you can see Tom1 is meowing, Tom1 is eating, Tom1 is running, and these are just repeated for Tom2. So this is how we can create different methods inside of our class, and this is how we can call them. Okay, so the general program doesn't have access to these variables here. So in order for us to find them and change them, we need to define certain methods that are called getter and setter methods, and these have to be one of each for each different variable. Okay, so now let's see how we can set the name. So we can define a set name method of self and also the name, and this just says that self.name is equal to this name over here. Okay, and then I can also do get name. Okay, and now I can just say return self.name. Okay, so now I'm going to repeat this for all the rest. So I'm going to define a set size, self and size, and we're just going to say self.size equals the size that we put in, and get size that just returns self.size. And then once again for the color, set color, and we just set self color to be equal to color, and then get color that just returns us the color of the cat. Okay, so now we can just say, let's delete this, and we can just print color of cat1, and we can do cat1 dot get color, and let's also print, actually let's set the color, so cat1 dot set color, we can set this to white, and now let's print new color of cat1, and that can be again get color. Okay, so let's run this. So you can see initially we have color of cat1 is black, but then we set the color to white via one of our setter methods, and then the new color of the cat is white, it's not black anymore. Okay, so let's take a look at some of the theoretical questions you are supposed to be able to answer by now. So first of all, what is a class and how do you relate it to a blueprint concept? How is a class different than an object? What are attributes in a class, and how attributes are different from the methods of a class? What is the role of the self keyword? How can you define the constructor method of a class? What is a class level variable? How are object level variables different from class level variables? And finally, what is the purpose of the getter and setter methods? Okay, so you are supposed to be able to answer all of these questions. So you can ask them yourself and figure out if you are ready to go to continue, or if you need to revise, just by solving these theoretical questions. Okay, let's take a look at the practical exercises you could do. So for today there is just one. Create a class dog with the attributes name, age, size, color, and dog count. The name, the age, the size, and the color must be instance level variables, but the dog count must be a class level variable. And then just create a method called print dogs, which should print just the dog count. So just take a look at these exercises, exercise. Try to complete it, because the classes and the objects are a very crucial part of programming, and it's a different way of thinking when you're doing object-oriented programming than just the function-oriented programming that you're used to.